Hello everyone. Today I want to show you my homework 7, number 1. I will talk about forward kinematics for a 6DOF robot using standard DH conventions. This is my homework 7. First, let's learn about the DH convention. It's a useful way to study robot kinematics. We need to know 4K DF DH parameters first. First, Joint rotational angle is variable. For this assessment, it changes between certain values. 2. Link offset. It's the distance along the z-axis of the joint. 3. Link length. It's the distance along the x-axis of the previous joint. 4. Link twist. It's the rotation around the x-axis of the previous joint. Then there's the standard DH homogeneous transformation matrix. What does it do? It described how the path changes from the conditioned system of link 1 to link I. Now let's look at the DH parameter of our 6DOF robot. The table here shows the value for each link. Let me explain some key ones with example. For joint 1, D is 0.6718. That means the offset of joint 1 along the z-axis is 0.6718. You can also see other parameters here, like center, I, AI, and more. They all help us build the robot kilometers model. Next, we will divorce the homogeneous transformation matrix for each joint. Let's take 1T0 and 2T1 as example. Such as this, we substituted the corresponding DH parameters of link 1 into the standard matrix formula. After calculation, we get the 1T0 matrix. What about other matrices? We use the same logical find their DH parameters substitute into the standard formula one by one to devise each matrix. Finally, we multiply all 6 matrices together. The result is 6T0, which is the key matrix for forward kinematics. To make our analysis more practical, we use MATLAB. Let's look at the code structure first. Joint angle conversion. We set joint angle in degree first, like 0, 90, 90, 0, 0, 0. Then we use degree to change them to their because MATLAB needs reduced for calculations. 2. DH parameter definition. We define each link parameter. For example, L1 is a link with parameters, and we may mark it as a dimensional unit using the standard DH convention. Robot modding. We use serial link to combine L1 to L6 into the complete robot model and give it a name. Forward conclusion with robot, we conclude the 6T0 matrix. Now let's see the result. First, there's the screenshot of the 6T0 from the MATLAB command window. Second, we got the end effort procession. That's the 3D position of the robot end. Third, the 3D robot visualization screenshot shows what the robot looks like with the set drawn angles. What do these results mean? Let's break down the 6T0 matrix. The first three columns makes up the rotation matrix. It tells us the end after the first three rows of the fourth column are the position value. They tell us where the end effector is in the base coordinate system. To check it, if our results are right, we can do a simple manually calculate the end after position when joint angles are simple. Then compare this manager result with the MATLAB result. They match well, which means our analysis is correct. This is my PPT. I want to show you another thing. This. Like this. Maybe again. This. And this. Okay, this is all my exercise. Thanks for your listening. Goodbye.